Well, we're going to get right to it. I know that weather was a lot to take in, and we might do a Zoom here soon and kind of follow up on weather and make sure everybody is understanding what we've talked about. But this week, we're going to talk about topography and fuels. We're continuing to talk about our fire behavior factors, but as you can tell, weather, we took 2 weeks just on that one of the three behavior factors. Topography and fuels, we're going to take 1 week to two subjects. So weather's a big deal. But let's start this session by just talking about topography. So, by definition, topography is the configuration of the Earth's surface. Its relief, its positions, its natural man-made features, mountains, valleys, rivers, lakes. This is all part of topography. And roads and man-made features like buildings and things are also, maybe not buildings, but roads and dams and things like that play a part in topography. The topography of an area is a fixed and known factor, and that's one of the big differences between topography and fuel and weather. Weather is extremely dynamic, changes from day to day. Predominantly, we are getting better at predicting weather, but weathermen are made fun of for their predictions and things of that sort. It's still a wiggly science. Whereas topography, yes, it changes over time through erosion, wind and water erosion, or through human efforts to change it. But for the most part, the mountain is where the mountain's going to be, and so is the valley. So topography is pretty constant. And fuels are, for the most part, as well, pretty constant, though they grow with time. They're slow changing, not fast changing like weather. So you do have variables that occur where we might have the fire. We'll have changes in topography as the fire continues to move, and we have to pay attention to that. And a great example of how important topography is, because I don't want to emphasize weather so much that you don't realize that in the absence of extreme weather conditions, topography is going to determine the speed and the direction of a fire. And a great example is the Marple fire in 1996. I was second in on this fire, and it was extremely significant for that year. It was the biggest fire of 1996. That area, here's some of the factors. The area had not burned in 28 years, so almost 30 years since they had had a fire in that area. The temperatures were definitely concerning, but the wind was not a huge factor. When the fire started, the winds were like 5 miles per hour. Later, as the day wore on, there were places in canyons that were getting 20 miles per hour. Temperature of 94, it concerns us, not as bad as when we get into triple digits. And humidity, 10%, that's just 1% away of being single digits. So these were all concerns. And our other topic of this week, fuel, is also a concern. And the fine fuel moisture readings were 2, which is very significant. Dead fuels were extremely dead. The grass was far gone. So Marple Canyon itself, this fire started at the bottom of the canyon. Some kid said it. He told the policeman that caught him he just wanted to see what would happen. So what happened was, an enormous, enormous fire. The elevation from the floor to the top of the ridges where the 5 is. Now, most of you that are listening to this, if you're a Southern Californian, you've driven through Marple Canyon, you just didn't know it. It's just past Castaic, and in fact, Castaic, the end of the road that goes through Castaic Road, ends in Marple Canyon. And when you go up the 5 or come down the 5 from Bakersfield or go up towards Bakersfield, towards Gorman and Lake Pyramid and all of that, you go past Marple Canyon, and it's that steep, very steep, straight down canyon that you're going up when you go up the 5 in that big steep grade. So at 12:30, the fire was reported, and the first on scene was engine 149. That's where I worked at the end of my career, but I wasn't working there then. I was on engine 76. We were there right away. They happened to be right down the street at the grocery store buying groceries. So they were on it right after it was called in. And they called it in as being an acre, but that it was rapidly growing. And by 6 o'clock, it was already 8,000 acres and growing. So this fire, look at how impressive this is. These are just some of the photos from that day. When the fire, I don't want to take a long time to tell this story, but engine 149 chased it with one reel line, trying to at least catch the one flank. It was burning in 4 different directions, and which is a rare occurrence. But because there wasn't a strong predominant wind, it was going with the lay of the land. And the canyon had basically 3 sides that were upward in motion, and it was backing down. So the part that was backing down, we didn't even concern ourselves with at that time. We tried to stop it on the most severe flank, and they burned through their hose. So they went back and they grabbed their second reel line. And now normally we wouldn't do a progressive hose lay with a reel line. You want something bigger. But this was a quick attack where we were trying to knock it down before it got too big. And so they grabbed the second reel line and chased it and burned through that one as well. I pulled up right after they had burned through their second line. They said, "Randy, we're grabbing your captain's side reel line." And I jumped off, put it in pump, and they started spraying water on it and burned through that reel line. Then they came back to get the other one, and right around then, the smoke was so thick, it choked my engine, and my engine stalled. I had to jump back in the cab, restart the engine, put it, go through the whole process of putting it back in pump and pulling all of my gauges, valves and gauges, and then they went after it with that last reel line, and by then it had hit the really steep slope and was gone. So they went after the other flank, gone. So right behind me, the fire had been progressing towards the hill behind me, and it had kind of got into some trees, and I thought maybe we could get that. We started attacking it, and it hit the grass, and once it hit the hillside, and as you can see here, super steep, it just went straight up this hillside. And this is a picture of that hillside that it was coming up. And the guys, this is Hazmat 76, the guys in Hazmat 76 said they saw the flame lengths that were going, it didn't spot across the freeway. It literally lapped over the freeway. I believe it's 4 lanes, maybe 5 lanes there thick. And the flame lengths were so long, they touched from one side to the other. So this was extreme fire behavior driven by fuel and topography. Barely any wind driving behind it. So ended up being a huge fire. So just an example of, in the absence of severe weather, I mean, it was pretty severe, but it wasn't extreme. Topography is going to play a big part. And, we have examples from history. The Man Gulch fire in Montana that killed almost a whole, the paratrooper guys. All of a sudden, I smoke jumpers, thank you. I just got it in my brain. Smoke jumpers, a whole smoke jumper crew, 3 survived. One of them was very famous, Wag Dodge. He started a little escape fire, and the crew did not know him well, even though he was the crew boss at that time. He was new to this crew, and they chose not to follow him when he said, wait for me, I'm going to light a fire. And they're all like, what? You're going to what? We're running from a fire. And he started this fire in the grass, and it burned away from him. And while he was waiting for that, the rest of the crew said, forget that. And they all started running. If they had followed his orders, they probably all or most would have survived. He went into the black that he just burned, and when the fire burned over, it went around him, and he survived. Of the 16, 14 or so that were still running, many ran in a kind of parallel to the top, but angling up. 3 of them turned straight and ran straight up. And they made it, except for one of them chose to jump through the fire that Wag Dodge had made and jumped through those flames and got burned really bad. The other 2 came to there was a cliff at the top, so they were going to have to run around this cliff, and as they were running, they saw a little cleft in the rock, and it was a gamble, because if they went in there and it was a dead end, they would have been trapped and the heat would have killed them. But it turned out that that cleft went all the way through the cliff, and they ended up on the other side. And those 2 survived the fire along with Wag Dodge. This fire was super driven by this topography. There was a wind going up. So this is southern aspect here, and the fire started up here and was backing down, but then some winds kicked embers across, and that's right when they were almost to where they wanted to be. They wanted to get under the fire and start working, and the grass spotted. It was all timber on this side and dead grass on this side, and the grass spotted below them, and that they ran this direction. And the topography aspect, slope, and an uphill breeze, those 3 factors, those alignment factors we want to look for. This is the Kramer fire in Idaho. Same thing happened. 2 firefighters died up here, and fire was working its way down, spotted across, ran up this hillside. And, you know, when the fire is going to go uphill fast. So here's Man Gulch. When you're looking at that last picture, you don't really get as much of a sense of how steep it is until you look at this. And this is what they were running up, is this kind of slope. Most of them died right in here where I'm circling. I hope that you can see my mouse. And all of this area burned. In fact, if we could see this photograph a little bit bigger, you would notice that a lot of the trees there are still dead from this fire that happened in the 1940s, late 40s, early 50s, somewhere around there. Another famous fire, infamous fire, South Canyon fire, where quite a few firefighters died, 16 or so. I get my numbers mixed up in my head, but they were working their way down on a fire, which is always dangerous, and it had been going for days, slowly backing down. Well, a storm, a cold front came nearby, changed the wind direction, and wind started going uphill instead of downhill, and it caught them. They were all above the fire when it had been backing down, but it wasn't a clean burn, so there was tons of fuel still left. And as they ran up this hill and tried to get over the top, most of them didn't make it. Quite a few of them were found with their tools still in their hands. So just remember that. If your crew boss says, let's go, let's run, drop your gear and run, both in Man Gulch and here in South Canyon, most of the crew members did not drop their gear like they were instructed, did not drop their tools. One female firefighter almost made it to the top, and she was found with her hand still grasping her chainsaw. You only have to wonder if she had dropped that chainsaw, if that would have given her just that little bit more to get over that ridge line and to safety. Everybody that got over the ridge line survived, and those that didn't all died. So, topography driven. Do you notice in all of these similar, big canyon, big gulch here, chimney, same here, very similar. And all three of them were near a riverbed, which creates unique wind type situations. So, what are we concerned about when we're talking about topography? Well, first of all, slope. Slope, aspect, and land features are our main three things when we're thinking about topography. So slope, by definition, is the degree of incline on which a fire is burning, and of the hillside where it might be burning. So slope contributes in quite a few ways. Preheating. Now, fire goes up, right? Convective air goes up. And if the hillside goes up, that heat is preheating the fuels. It's also spotting ahead, because anything dropping is going to drop uphill. And if the breeze is that way and the convective heat is going that way, not only that, but the fire presents the heat to the future fuels that it's right there. It's going to them. So those three things are a big deal. Why slope is a big deal. Uphill fire, the steeper the slope, the faster the fire. The closer the fuels are to the flame front, the faster the rate of spread, the narrower the flame front. It will look like a tight V. The steeper the slope, the faster it'll go, and the tighter the V will be. Now, a downhill fire, this is a great place to make progress on a fire, because it's going to burn slower. The fuels are on a declining slope, so they're not getting that preheating. They're farther away. Now, we have a big deal of the impact of slope on the rate of spread. So this is a test question. A fire will double in rate of spread on a 30% slope. On a 55% slope, it will double again. So never underestimate how fast a fire may move up a slope, especially in light grass. So not only is the steepness of the slope important to us, but where the fire starts on a slope can also have an effect on fuel availability. If you look at slopes, depending, we're going to talk about aspect, depending on which aspect it is, but towards the bottom of the slope, you're going to have heavier fuels, because that's where the rain runs down to, and it gets a little less sun than on the top of the slope. So on the top of the slope, sometimes it's even bald, right? So ridge lines have less fuel. So there's usually more fuel at the base and mid-slope sites than up on the top. So more fires will burn over 10 acres if they start at the base of a slope, and oftentimes the base is a road, and that's where a lot of our fires start, especially in the wildland urban interface. So if a fire starts at the bottom, it's going to get bigger. If it starts at the top, no matter which way it goes, it's going to be a backing fire. If we can get to it in time, we can keep it pretty small. So our second issue with topography is aspect. Now, we talked about aspect early on, and you've been given an aspect project. So I don't want to beat a dead horse here, but I also just want to repeat that information. So aspect is the direction that the slope is facing. So when you're looking at a mountainside, that's not the aspect. The that direction you're looking. The direction the mountain is looking is the aspect. So if you walk up on the mountain, turn around and look the same way it's looking, and look down at your phone, whatever that compass on your phone is saying, or if you have a compass, that's the aspect that you would refer to it. So an east aspect faces east. A west aspect faces west. The orientation of the slope to the sun is what we call aspect. Now, the impact of aspect on fire behavior changes throughout the day because the part of the hillside that's getting the most sun at that time has their fuels, the temperature rises. So the north aspect consistently has greener fuels than the south aspect because the south aspect gets more sun. But on the other hand, from day to day, see, that might be from season to season, but from day to day, the south aspect is also going to get sun from anywhere around late morning to mid-afternoon. It's going to get full sun. And that's one of the reasons why it's one of the most dangerous. So if you look at this little chart, east aspect, we don't even consider it having hot fuels. Now, can a fire burn ferociously on an east aspect? Yes, it can, especially if it's wind-driven. But normally, here in Southern California, wind is coming out of the southwest. So the east side is on the lee side. And the east side is out of the sun and in the shade sometimes by 11 o'clock, 10 o'clock. So its shaded fuel isn't as hot. One of the later aspects to turn from green to brown if it's got grass on it and light brush. And north aspect even more so. The north aspect barely gets any sun. And if it does get sun, it's when the sun is at its zenith at 12 o'clock in the middle of the day, in those couple hours before and after. But we don't even consider north aspect to have anywhere of a preheating from the sun factor like south, southwest, and west. Now, here in Southern California, our south and southwest, west slopes are the location of some of our most horrific fires. You constantly, in fact, right now as we're speaking, there's a fire over in the Azusa area on that south-facing aspect of the Angeles National Forest, and it's been quite a big deal. They're kind of getting the upper hand on it now, but it's typical La Cañada, Flint Ridge, Altadena, all of these areas along the face where it's south-facing in the Angeles and Los Padres National Forests are some of our worst fires. So during the day, the sun moves across the sky and it radiates down to the different aspects at different times of day with a different amount of intensity. So the air temperature as well as the relative humidity change, but even more of a concern to us as we're talking about topography and fuels, the fuel moisture will dry up and the fuel temperature will increase. So all of these things will change on those different aspects. So let's just review a little bit. And if you're doing your aspect project, you should do at least one slide for north aspect, east aspect, west aspect, and south aspect. Then you're going to do 4 more slides. Don't forget that. A lot of people forget that. They don't read the stinking instructions. Read the instructions on how to do this project. You're going to do 4 more slides on different kinds of fuel. Just tell me about some fuels. Maybe you'll just say, here's a picture of light fuels, here's a picture of medium fuels, here's a picture of heavy fuels, here's a picture of timber fuel. Whatever you want to do, you might, here's a picture of a yucca plant, here's why it's significant, but don't forget to do that part too. But you should, on your hike, be taking a picture of a north aspect, an east aspect, west and south. Remember, when doing your project, try and take a hike in an area that hasn't burned recently. It's getting harder to find those areas because so much has burnt. But north aspect usually has heavy fuel, greener fuel, higher fuel moisture, lowest average temperature of your fuels, lowest rate of spread. The fire will burn slower, but if it does get into the crowns on a north aspect, and especially if it's wind driven, it can still be very intense because you've got heavier fuels, you've got more BTUs. For the most part, though, fire on the north aspect is calmer than fire on the others. East aspect is a transitional aspect. Heats early in the morning, but then cools. It's generally the lee side of the mountain. That means the wind is blowing over it, or it's sheltered from the wind. West aspect is also a transitional, but contrary to common belief, most of your literature is going to say south aspect is your most dangerous. And there are a lot of reasons why the literature says that. But if you look at history and the devastating fires, more and more of them had happened late in the day on southwest and west aspects. Glen Allen, Loop Fire, Calabasas Fire, Man Gulch, 30-mile fire, South Canyon fire. All of these fires were late in the day and were on either south, southwest, and west aspects, but a lot of them southwest and west. So even though it's transition, and it's going to kind of be as dry as south, but not as much, this is generally the windward side of the mountain. And that's a concern, because when you have wind, slope, and aspect in the favor of the fire, that's bad news for firefighters if you're in the way. South aspect, driest, lightest fuels, usually just dead grass. So, I encourage you, when you're out and about driving, look at the different hillsides and what directions they face, and notice the difference in fuels. So a great example is when you go from the San Fernando Valley into where I live in Santa Clarita, you go through what we call the Newhall Pass. You look to the south at the north-facing aspect, and you're going to see heavy timber, green. They did have a little bit of a fire in there recently, but still that area has got big oak trees, very green, compared to, you look north, which is the south aspect, and it's dead grass, it's dark brown, it's exactly as described here. Earlier curing, it's the first ones to turn brown, earlier snow melt, highest rate of spread. So this is what I was saying earlier. South and southwest aspects are dangerous in the afternoon because they're the most vulnerable to fire. The fuels are usually lighter. They're warmer. The day has warmed up. It's the hottest part of the day is, right? Between 2 and 4 o'clock. So that's when it's hitting. The sun is on that southwest and west aspect. So all the ingredients for a blow up or extreme fire behavior are there. So south and west facing slopes normally burn hotter in the afternoon. So watch out. There's another There's another feature to this, that most of our fires start, in the early afternoon. And if you've been fighting fire all afternoon, and then by 4 o'clock is when the blow up happens, now you're tired, you've been breathing carbon monoxide, you're not at your best, and it makes you more vulnerable too. So just remember that. Make sure you've always got your watch out senses turned on when you're on south and southwest aspects late in the afternoon. So this is the point I was making. South Canyon, Man Gulch, Glen Allen, Loop Fire, Kramer Fire, all of these, look at the time of day. 4 p.m., 5:45, 4 o'clock, 3:30 to 3:35, and 3:25. And all of these were south-southwest aspects, west aspect in Glen Allen, west-southwest in Man Gulch. So I think I made my point. And then, just showing you again the Kramer fire. This fire burned down here, but it spotted across and just blew up this. And this is where the 2 firefighters died. Okay, let's move on to shape of the land, or the land features. And we're almost done with topography. So the configuration of the lay of the land affects wind patterns. It affects fire spread, ridges, saddles, canyons, chimneys, and elevation, as well as barriers like rock outcroppings or man-made barriers can all have a direct influence on how and which direction a fire will burn. So ridge lines provide a great break between slopes, and they're oftentimes one of the best places to construct a indirect fire line in steep country. Also, a lot of times the ridge line is, you need to get up and over the ridge line if you are escaping from an oncoming fire. So if there is an opposing wind that's present, sometimes it may reduce the level of spotting, but if there are converging winds along a ridge line, you can get an eddy effect. And this is a great picture, reinforcing my point. This is a great place to make a nice, good fire break, get some distance between the fire and the other side of the mountain, and then hopefully we don't get any spotting over here and we can stop this fire. Canyons. Now, when we talk about what's the difference between a valley, a canyon, and a chimney, it's the narrowness. So the narrower the canyon, the more extreme the fire behavior, and you can have intersecting drainages. These are always difficult and dangerous places to fight fire, not only for your own footing as you're moving around, but also the fires have a tendency to be funneled, and the winds get funneled and accelerate. And so canyons can have the same kind of effect on a fire as a chimney, in your home. It drafts the heat up. And so all of the factors are in the fire's behavior. Not only does heat normally go up, but now the canyon is pushing it up with its steep slopes. As the heated air moves up and out of the canyon, it draws more air in underneath, bringing in oxygen and increasing the intensity of the fires. And then again, when winds cross openings to drainages or get up and over ridges, sometimes we get eddies and even tornadoes. In the Man Gulch fire, there was a fire management officer that was down towards the bottom of the hill waiting for the crew to show up, the smoke jumpers on their way down to him, and the wind kind of picked up, and it was one drainage meeting the river, so the winds from the river were going one direction, the wind going up the canyon was going another, and the prevailing winds from that day were coming up and over the other ridge, and what it created was a tornado. And this tornado picked him up off of the ground, and he was very fortunate. It threw him away from the fire. So he literally got lifted off the ground, spun around a little bit, and it threw him out into the unburned area. If it had thrown him into the burn, he probably would have died, but he was fortunate, and he lived to tell the story. So the narrower the canyon, the more preheating, the more spotting, the more chances of ignition on the opposite slope from the radiant heat, and the more potential for erratic winds. So a really, really narrow canyon, or maybe even just a draw is what we call a chimney. Chimneys have been involved in a lot of injuries and deaths of firefighters, and it's just a steep, narrow chute canyon, and sometimes they're so steep and narrow, and if you are in overgrowth, it's kind of hard to see. The combination of topography, weather, and fuel can really create havoc in a chimney because the fire just gets funneled in there and increases in intensity. But quite often when firefighters have had luckily been able to escape a fire that was burning them over in a chimney, quite often they'll say, we didn't realize we were in a chimney. Because sometimes you just can't tell because of the growth around you, and you don't have the perspective to see. You're on a steep part, but you may not know that you're in a chimney part. So one of the things that I try and tell students is, chimneys and canyons and valleys are all where water will funnel down. So when it rains, the water gets channeled into these areas, and so the water drains there. So here's what I say. It's kind of a rhyming thing. It might not make sense to you, but where water drains, fire reigns. But the second one is R-E-I-G-N-S, like a king reigns. Where water drains, fire reigns. So rain is going to drain there and leave erosion marks. So if you're looking down and you can see erosion marks from this is a place where water accumulates when it's raining, you're probably in a chimney. And the fire is going to go up faster than that water goes down. So just remember that. If you see, when you look down on the ground, that you're in a place where it's a drainage, that's a place where fire is going to go rapidly up. Okay, so normal upslope air is funneled, accelerated in a chimney, and the narrowness brings the fire closer to it. And if the type and quantity of fuels is conducive to a rapidly spreading fire, it's just going to go up a chimney way faster than any firefighter can run. And next week we'll look at the loop fire, and you'll see an example of that. So chimneys are fire traps. So these are chimneys, right? These are all chimneys. But then there's some little chimneys inside the big chimneys, right? Right here I can see one. And right here I can kind of see one. Okay, right, actually in here. And then right in here. So chimneys are sometimes hard to spot. So another thing, if there is a road nearby, if you're on an outturn, this is an outturn, well, that's a ridgeline. If you're on an inturn, that's a chimney. So be aware. Okay, last couple of slides here. Barriers can be natural or man-made, and they can really help us as a place to help our fire line, lakes, ponds, streams. Be aware, though, that if you do have to go into water, usually if you're in the high country, this is freezing cold water, it's snow melt. So just be aware that if you do have to use water as an escape area, a place to deploy, even people have deployed in water and covered themselves with their shelters. But just be aware of that. Meadows, roads, trails, all of these things. Rock areas are helpful, and there's not as much fuels in there, but there are fuels. Don't be fooled by a rock slide. There are fuels in there. There's always lots of dead leaves and pine needles and pine cones, etc. And also, it's almost impossible to get a seal with a fire shelter in rocks. So just remember that. Last slide. Change in fuel type when you have barriers can actually really help you. So old burns or the black, any other natural or existing feature can be a barrier. So take advantage of existing barriers if they fit with your plan, and they could be a place that you can use for starting a line or for adding to your line or even to be a place to escape to. Okay, sorry that was longer than I thought. I always say that, don't I? I always say to my wife, oh, I ate too much. I can't believe I ate that much. Well, I always say to you guys, this was longer than I thought it would be. Sorry about that. Okay, well, this was good information, though. We're going to move on to fuels here in a second. Maybe I'll do better on that one.